I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We are organizing 20,000 videos on the YouTube in this particular website, Global Math Institute. And I hope that will be an asset for the students all over the world. Keep sharing your thoughts and questions that will improve the quality of our website. Now here are 5 related questions on inverse variation. We'll talk about the basic concept and then take up solution of these 5 questions. And I hope that will help you understand the inverse variation in greater details. You can always pause the video, copy these questions, answer them, and then look into my suggestions. So now let's straight away get into the concepts and then we'll write down the solutions for each of these questions. What is inverse variation? So basically in inverse variation, what is happening here is that if you look into a coordinate plane, in that case, if the x value is increasing and y decreases, that is called inverse variation, right? So something like this. So when we say inverse variation, then in general, we say if x increases, y decreases, right? So that is what inverse variation is, right? It could be linear, it could be non-linear. Now, based on this, we have 2 other very common terms which we are going to use in our questions also. And one is we just say x varies inversely as y, or we may say x is inversely proportional to y. So these are the 2 statements which will show you inverse variation, correct? Now, if I say inverse variation, it really means what? Well, if I say that x is proportional to 1 over y, that is inverse variation. In that case, we could write x is equal to some constant into 1 over y. Is that clear to you? Right? So if I am given few points on a line, we'll find out the value of constant and then solve related questions. We could also have scenarios where we say x is proportional to 1 over y square. So it could be proportional to, inversely proportional to any other function of y, right? So this could also be written as x is equal to k times 1 over y square. Now in both these equations, y is in the denominators, so there is a note which is very important, and that is y is not equal to 0. And therefore, if you have inverse variation, 1, the graph will be going downwards, right? So 2 things happen. One is that we see graph moves downwards, and second is graph will never go through the origin. Correct? Since at origin y is equal to 0, right? So these are Basic things which you need to understand before getting into solving questions based on inverse variation. Correct? Now I think we are ready for solving more questions. So let's take up the very first question now. It says t varies inversely as s. So t varies inversely as s means t is proportional to 1 over s, right? That means t is equal to some constant times 1 over s. Now the second statement is t is equal to 20 when s is equal to 100. So we are given that t is equal to 20 when s is equal to 100. So we'll substitute these values to find the value of k. So we have 20 equals to k times 1 over 100. And so we have 20 times 100 equals to k. So the value of k is 2000. Is that clear to you? So we found the value of k from the given condition. Now we have two related questions, A and B. Let us see how to solve these questions. Question number A is the value of t when s is 20. That is what we need to calculate, right? So we need to find what is t when s is equal to 20. So we know now that the relation is that t is equal to 2000 times 1 over s, right? So I could write this relation here that t is equal to 2000 over s. So we can always use this equation to solve related questions. S is 20, so we have 2000 over 20. So that cancels and we get 100. Correct? So for a value of s to 20, we have t equals to 100 for s equals to 20. Is that clear to you? Now let's take part B, where we are given t is 60 now, right? So we are given t equals to 60. We need to find what s is. So we have the relation that t is equal to 2000 over s. We can rearrange and write s equals to 2000 over t. And so what we get here is 2000 over 60. So that can be divided. And we can now divide this by 2 also. So we get 100 over 3 as the value of s. Is that clear to you? So this time we have the answer that if t equals to 60, s is equals to 100 over 3. Is that clear to you? Perfect. So that is how we can actually solve related questions. I hope that makes sense. Now you can move on and solve question numbers 2 to 5. Question number 2 is x is inversely proportional to y square, right? So that means x is inversely proportional to y square. That means x is proportional to 1 over y square. And that also means that x is some constant times 1 over y square. If x equals to 4, y equals to 3. So we're given x equals to 4, y equals to 3. So that should help us to find the value of k, right? So we get 4 equals to k times 1 over 3 square, which is 9, right? So get 4 times 3 square is equal to k. So that is 4 times 9 is k. So k is equal to 36. So once we get the value of k, we can always write down the relation, and that is that x is equal to 36 over y square, correct? With this equation, we are going to solve part A and B. Part A is the value of x when we need to calculate the value of x when y is 2. Right? So that is the equation. The equation is that x is equal to 36 over y squared. 36 is the value, the constant. Substituting the value 2, we get 36 over 2 squared, which is x equals to 36 over 4. And so we get x equals to 9, right? So we get our solution as 9 and 2. Clear? That's simple, correct? 2. Find the value of y when x is 9. So we're given x equals to 9, we need to find what y is. The equation is x is equals to 36 over y square. Let's rearrange. So y, let's say square, is equals to 36 over x. So what is y equal to? Y will be square root of 36 over x, but whenever you do square root, you do plus minus. So you get plus minus 6 over square root of x. Does make sense to you? So we get two values, right? So we get y equals to plus minus 6 over square root of 9, which is plus minus 6 over 3, or we get y equals to plus minus 2, right? And therefore, our answer here is that x is equal to 9, y equals to plus and minus 2. So there are two solutions for this. Perfect? So I hope it is making sense. So let's move on and take the next question, which is question number 3. X varies inversely as y minus 3. So we'll write down the equation that x varies inversely as y minus 3. That means 1 over y minus 3. So that means x equals to k over y minus 3. If x is 3, y is 5. That is given to us. That will help us to find the value of k. So we get 3 equals to k over 5 minus 3. So 3 equals to k over 2. Or we get 3 times 2 equals to k, which is 6. Right? So that gives you the equation, which is x is equal to 6 over y minus 3. Correct? With this equation, we are able to solve the two parts. We know that x is equal to 6 over y minus 3. A is calculate the value of x when y is 6. So we need to find what x is for y equals to 6. So we'll substitute. Get x equals to 6 over 6 minus 3, which is 6 over 3, and that is 2, right? So we get x equals to 2 for y equals to 6. Now let's do part B. The equation is x equals to 6 over y minus 3. And what is given to us is calculate the value of y when x is 2. So if x equals to 2, we need to find what y is. So let's rearrange, right? So we can say that y minus 3 is equal to 6 over x. Or y is equal to 6 over x plus 3. So 6 over x is 2 plus 3. So we get y equals to 3 plus 3, which is 6. So this time we get the answer as 2, 6. Perfect? Now let's take question number 4. Now here we have a table of values which we need to complete. Question number 4 is, given that x is proportional to 1 over y square, complete the table. I'd like you to pause the video, answer this question, and then look into my suggestions. Question number 4. Given that x is proportional to 1 over y square, so we write x is proportional to, I wrote equal to, so we write k over y square, a constant times, right? So that is how you can change the proportionality. Now, we have one relation for x, we can also find relation with y, right? So that also gives us that y square is equals to k over x, right? So we could actually write it in both ways. But the idea here is to first find the value of k. You can find the value of k from one set of values, 4 and 5. So we are given that x equals to 4, y equals to 5. Using this, we can find what k is. You will notice that in inversely proportional relations, k is basically product of x and y square in this case, right? So whatever it is inversely proportional to, that product is constant. So let's just multiply these two. So get 4 times 5 square. So that gives us a value, 25 times 4 as 100. So we get the value of k as 100. And so we can write down the equation as x equals to 100 over y square, or we can say y square equals to 100 over x, since k is equal to 100. Is that clear to you? Now, in the second equation, if I need to isolate y, we'll do y equals to square root of 100 over x, and whenever you do square root, you have to write plus and minus. So we get plus minus 10 over square root of x as our solution. Perfect. So both x and y cannot be 0. Okay, so now let's find these solutions, right? Okay, so let's find the x values first. So these two, so we have x equals to 100 over, we'll write 2, right? So 2 square. So that means 100 over 4, and this is 25. So this value here is 25. Now for that place, we have x equals to 100 over 10 square, so which is 100 over 100, and so we get a value which is 1, so this value is 1. Is that clear to you? So let me rewrite clearly, just 1. Okay. Now let's find the value for y. As you noticed, there could be two values for y, right? So the first one is when x is 1 over 4. So we have y equals to 10 plus minus, of course, square root of 1 over 4, which is plus minus 10 over, square root of 1 over 4 is half, right? So that gives you a value of 20. Right? So this value here is 20 for us. So that is how you get the value of y. So we find that when x is equal to 1 over 4, y is equal to plus minus 20. Right? So there are two solutions. Clear? So I hope this helps you, right? So in every inversely proportional, we know constant is product of the two. The last question here is again a table similar to what we just did. Slightly difficult function to work with. It says question number 5, given that x equals to k over nth root of y, find k and n, then complete the table. So it's slightly complicated. Let's say this is a bonus question for you. Okay, so we are given that x is now equal to some constant over nth root, right, of y. We are given one set of values, 12 and 1. So let us substitute these values. We know x is equal to 12 and y is equal to 1. So what we get here is 12 equals to k over nth root of 1, so which is just equal to k. So we find that k is equal to 12. So we get the value of k as 12. So I think something is missing. So what I will do here is I'll write a value 6 here and then continue, right? Because to find k and n, we need to have two sets of equations, right? Okay. So I've introduced one set here, and we are going to now use this. So what we get here is that x is equal to 12 over nth root of y. We'll use the second set where we are given that x is equal to 6 when y equals to 8, and the equation is x is equals to 12 over nth root of y. Substituting, we get 6 equals to 12 over nth root of 8. And if I cross multiply, then we get nth root of 8 as equal to 12 over 6, which is 2. Well, that is possible only if n is equal to 3, right? Cube root of 8 is 2, right? So we get n equals to 3. So we find n equals to 3, and therefore now we can write the equation x is equal to 12 over cube root of y. Does make sense, right? How did we get this value? Since 2 cube is 8, or we can say cube root of 8 is 2, right? It is because of this. Okay, now we have a relation and we can now find solution. Good. Slightly more complicated. So now let's find the first thing, which is we are given y as 4. We need to find what x is equal to, right? So let's substitute. So get x equals to 12 over cube root of 4. Right? So that becomes the answer for x. So that is the exact value, correct? Cube root of 4. And if for the condition, so we have this question here as 12 divided by cube root of 4. The second case is when x is equal to 2, what is y? Okay, so if x equals to 2, we need to find the value of y. Okay, so what we can do here is that we can just rearrange, right? So we get cube root of y is equal to 12 over 2, which is the value of x, which is 6. So y is equal to 6 cube. Is that clear? So y is equal to 6 cube, which is 36 times 6. So the value of y is 6 times 6, 36, 3. 6 times 3, 18. So 216. So we get the value of y as 216 in this case. So I hope that makes sense. So anyway, except for some missing data in the last question, I hope everything went on fine, but you have understood the concept, right? So we actually understood the concepts for inverse variations and we solved these questions. We assume that this value is 6. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.